biologists J. This is Jay. After testing out our bug shirts, which are not seen in the previous clips, the team headed to the airport where we flew into the study area on Banks Island. As you can kind of see here, the plane that flew us in has special Tundra tires, which are oversized balloons that allow it to land on rough terrain. The plane flew us 3 hours from an airport in Aulavik to the base camp location on Banks Island, within Aulavik National Park. Aulavik National Park represents a significant piece of Inuvialuit history. The name Aulavik is Inuvialuktun for a place where people travel. It is the site where the Thule people occupied and lived during the years 1000 to 1450 AD. These people would eventually move south to inhabit the southern parts of the island and the coast of Alaska, stretching across the Yukon and the Northwest Territories. The descendants of the Thule people are now called the Inuvialuit. Banks Island in Aulavik National Park contains critical habitat for a variety of plants, the breeding grounds for many bird species, habitat for prairie caribou, Arctic wolf, and has one of the largest muskoxen populations on the planet. Base Camp, or Green Cabin, is a green plywood structure built to act as refuge for researchers in case of storms, a place to store equipment, and where we set up our tents. Study sites on the island were accessed from Base Camp via helicopter. One of the many tasks we set out to accomplish while on the island was to monitor 7 different slumping sites. These sites are monitored every year by flying drones over them using LiDAR technology to create 3D maps of the thaw. Now, a quick note on the equipment used. Regular DJI drones can be purchased with a package that sees them outfitted with special sensors and cameras capable of providing LiDAR technology. However, because this is science facilitated by a government entity, there is also a custom drone that is way more expensive that can be used. For a starting price of only $20,000 US, an EB can make acquiring funding for your scientific endeavor very achievable. Now that crazy price gets you a specialized multi-spectrum sensor and LiDAR technology all outfitted on a sturdy 100% styrofoam frame. In order to accurately create the model with correct spatial information, the EB needs 3 points of reference. We would walk around the slumps, placing 3 white high-tech Rona bucket lids around the perimeter of the slump for the drone to use as reference. Using survey equipment, the exact location, elevation, and position of these circles are calculated and bounced to the drone, which then triangulates its position and compares the points of reference to its satellite information, allowing for accurate up to the millimeter scanning. Now, one thing that is hard to describe and get across with words is just how eerie it was to see this. This was probably the first time I've ever seen climate change manifest itself in front of my eyes so obviously. Being able to get a bird's eye view and to see how the land is slowly sinking into itself is astonishing. There's no denying that the change is radical. Slumps like these are appearing more and more frequently throughout the landscape every year. Anywhere that has permafrost is vulnerable to this type of disturbance. On Banks Island alone, the amount of slumps has risen from 63 to 4,077 in the last 30 years. The headwalls on some of the slumps were over 15 feet tall, and you could see exposed ice thawing away. The crazy part is that most of that ice is over 10,000 years old. I think talking about climate change can be hard to visualize for a lot of people, including myself, but actually being able to see right in front of your own eyes what things like warmer, longer summers and late season rainfalls is actually doing is very profound. The crazy part is that this is something that isn't happening slowly, gradually over time, where you have to wait years to witness change. Multiple feet can melt back per day, and it's happening right now.
Translational and retrogressive, if that's possible. Status is active. Size is medium, and there's only one. Parapite less than 5. Connectivity 0. Geomorphology fluvial. Ground ice not visible. Becoming a thaw slump.
These captivating shapes are called ground polygons. They are formed over many years of repeated freezing and thawing of surface moisture during the spring and fall. In addition to being rather beautiful, recording features like this along with other topographic information allows researchers to track how the landscape changes over time. While we were flying around, we also were to make note of the species and number of individuals for any wildlife seen from above. By repeating these flights on the exact same flight path every year, long-term continuous data becomes available.
Under mass wasting again. Type is thaw slump. Characteristic is retrogressive. Type is lowland. The characteristic is high and low centered polygons and polygonal pattern funding.
It quickly became apparent that slumps, along with polygons, were everywhere. It didn't matter which side of the transect you looked. When slumps with active headwalls and exposed ice were spotted, we would land to gather samples of the headwall ice. There are not many videos or photos to show of this stage, but it is accomplished by drilling into the headwall to collect pieces of the active layer to bring to the lab for isotope analysis. For all the measurements done on this trip, it was crucial that everything was done in a way that allows it to be repeated exactly the same way each year in order to be able to track the change. Seen here, we are drilling into the ground to take ice core samples and to install thermometers into the ice. On our trip, we stopped 4 times to take cores and to install these thermometers. They have a battery in them that allows them to keep a log of temperature data for up to 7 years at a time. These were installed in areas that currently did not have any active slumping, with the purpose of tracking the ground temperature. Now, technically it is incorrect to call these samples ice. The samples are permafrost samples, which means they can be composed of a variety of sediments and may not appear pure white like ice. In total, permafrost stores around 1.5 trillion metric tons of organic carbon. That's double the amount that is currently in the planet's atmosphere. I hope that by being able to visualize the process undertaken in this project, it helps you to better be able to picture what is at stake when considering Arctic thaw and the release of gases like CO2 and methane. As well, I hope that this puts into perspective how habitat and infrastructure can be put at risk with a future of continued warming.